Hello, and welcome to the Tentative Tutor channel. Ragnar has a bag full of 17-ounce silver coins. He wishes to pay a merchant 542 ounces for a horse. The merchant only has 11-ounce coins. What's the smallest number of coins they need to make the sale? Can you solve this? Leave your answer in the comments. First, let's notice that 17 and 11 are relatively prime, and the merchant can make change for a purchase worth 1 coin. So let's multiply both sides of the equation by 542. Applying the distributive law, we get that the merchant can make the transaction with 1084 plus 1626, which is 2710 coins. Is this the best we can do? Pause the video and see if you can work it out. I'll solve this problem in 3, 2, 1. This is the general theorem for equations of this type, which will give all possible solutions. We're looking for all x and y for which 17x minus 11y is 542, and we know that 1084 and 1626 are two solutions. So here a is 17, b is minus 11, our two solutions x naught and y naught are 1084 and 1626, and d, which is the greatest common divisor of 17 and 11, is 1. And this is what all the solutions have to look like. X is 1084 minus multiples of 11, and y is 1626 minus multiples of 17. So if we remove multiples of 11 from x and multiples of 17 from y, we should be able to get a smaller solution. What's the biggest number of multiples we can remove? Well, we can see that 11k has to be less than 1084, so that x stays positive, and 17k has to be less than 1626. So we need only solve these two inequalities. Dividing both sides by 11 on the left and by 17 on the right, we get k is less than 98.55, and k has to be less than 95.65. Keeping in mind that k is an integer, the best we can do would be k is 95. So we subtract 11 times 95 on the left and 17 times 95 on the right, and we can see that we get an answer of 39 for x and 11 for y, which means that Ragnar would pay the merchant 39 17-ounce coins, and the merchant would pay Ragnar back 11 11-ounce coins. And that's a total of 50 coins. So 50 coins is the answer, and we can check it by doing the arithmetic. Now here's our bonus problem. You have a 3 and 5 liter container. You also have a running tap. You must use the containers and the tap in such a way as to exactly measure out 4 liters of water. Can you do it? Give us your response in the comments, and thanks for watching.